So if you recall where we left off last time, we had talked about the handy microservice. We talked about the structure and functionality and the implementation of the handy microservice. What we're going to do now is shift our attention to the Zippy microservice structure and functionality. And as you'll see, we have a multi-part set of lessons here because there's a lot of stuff going on in this particular part of the case study, most of which is relevant for different parts of the upcoming assignments. So we'll start out by talking about how the Zippy application microservice is designed and how it integrates with the Jakarta Persistence API or the JPA. And we're going to focus here quite a bit on Java Spring annotations that enable persistence and caching. So let's start off by taking a look at the application itself, which is quite a bit different from what we've looked at so far. So as usual, we have an application, in this case, the Zippy application, that provides the entry point into our Spring WebMVC-based version of the Zippy Quote microservice, which you can get at this link down below. As we did with the handy application, we extend the base application, which defines the run method used by both handy application and Zippy application, and also defines a few other beans that are used to make sure that each incoming request that arrives from a client is going to be handled by a virtual thread at the lowest level of the incoming request stream. Here's the call we make to our base application helper method, which is used to build and run the microservice by doing the dependency injection and all the other things that are needed to get a Spring application up and running. Speaking of Spring applications, we use the Spring Boot application annotation to enable auto configuration and component scanning. That's pretty much par for the course. Nothing is too surprising yet. This is all what we talked about in the context of the handy application and the handy microservice. So let's now turn our attention to some new stuff. The first thing you'll see here is a new annotation called Enable JPA Repository. And this annotation enables the use of the Jakarta Persistence API by scanning the given class, which we'll talk about in a second, for Spring data repositories. And in fact, we're going to tell it to go look at the Zippy Quote repository class, which is a JPA repository that will perform the CRUD or create, read, update, and delete operations on Zippy Quote objects. So you can see on the left-hand side, we kind of show what the form of that Zippy Quote repository is, and we'll talk more about that in the next part of this lesson on the Zippy microservice. We also have another annotation. This one's called Entity Scan, and this is used to tell Spring which packages to use when scanning for entity classes. Entities are the part and parcel of persistence with the Jakarta Persistence API. And an entity is basically a class with some special annotations, which we'll talk about shortly. And this is what that class is. It's the quote class. And that's the entity class that we're going to use to store quotes persistently for the Zippy microservice. And it's also used to store quotes non-persistently for the handy quote microservice. And we do that once again by using some cool annotations, which we'll look at later. The next annotation we're going to use here is enable caching. And this tells the application to use Spring's annotation-driven cache management capability, which is often useful for so-called read-only methods. For example, methods that would return the list of quotes. Those conceivably don't change. We have a fulsome list of Zippy quotes at the beginning. They're put in the database, and once we start, they never are updated. And so you can see in the diagram on the left-hand side of the screen, when a client talks to the web server here, the web application, what it'll do is the first time through, it'll go ahead and have the service read the database to get the contents of the Zippy quotes. And then those will automatically be stored in this server-side cache. And henceforth, when the web application goes back to access that content, it'll take it from the cache rather than going back to the database. And we'll talk about how that works and analyze some of the pros and cons of that approach. These declarative annotations, enable JPA repository, entity scan, and enable caching, allow us to use a bunch of powerful Spring features without having to write much, if any, Java code. So we don't have to write the caching code. We don't really have to write the way in which we're going to connect things together for the JPA repository. We don't have to do the entity scanning. That's all done for us automatically using the annotations that we provide here. So very useful to know these annotations, and you'll get a chance to apply them in upcoming assignments as well. Let's also spend just a bit talking about the structure and functionality of the ZippyController. This, as usual, is going to take the client requests, both get and put requests, get and post requests, and it'll map them to endpoint handler methods using the ZippyController subclass. As you can see here, the ZippyController extends BaseController, and therefore it overrides and defines 5 endpoint handler methods like get all quotes, get quote, post quote, search EX, search, and so on, that are defined in the BaseController. So we don't have to rewrite those methods. We just inherit them by extending from BaseController. So we're not really overriding them, we're just leveraging them. And if you look at the BaseController, you'll see that they just turn around and forward to the corresponding service implementation methods. Another thing we do here is we define the classic Java list type as the return type for the various methods that are defined in the BaseController. So if you take a look here, those are all generic methods that return generic type T, and we define that type T to be a list of quotes. So that, of course, is going to provide a list of quote objects back to the client in response to the various get and post method requests that come in from the client. And again, of course, as usual, we use the REST controller annotation to ensure that the request handling methods in the controller class, the ZippyController, will automatically serialize their return objects into HTTP response objects, thereby making this whole thing work seamlessly so that the client gets back something that it expects. So that's the walkthrough of part 1 of this discussion of the structure and functionality. The main focus here really is on some of the interesting new annotations we have on the Zippy application to allow it to support persistence and caching without us having to write a lot of code imperatively.